Hey there! Hopefully if you're here, it's because you've already done the first part of this worksheet. And the first part was called Molality and Colligative Properties. Your date may be different depending on the class you're in, but the paper was Molality and Colligative Properties. The first part of that paper was a lesson from Professor Dave, and he explained how the molality and colligative properties worked. And so hopefully you filled that out. Let's open up this paper and see what it says. Well, actually, I already have it open. Let's check that out. All right, there's the Professor Dave part. And then here's the Mr. Arnold part. So the first thing we're going to do is we're going to look at this equation. Now, this is the equation that we use. I got to keep my phone alive here. This is the equation we use to solve for the changes in the temperature of the boiling point and or the freezing point of a solution. We have three different parts of this equation. I'm going to use this little arrow here. I'm going to use this thing, and I'm going to say what this is. Delta T, of course. Delta means change. So delta T means, let's not do it that way. Let's do it this way. So delta T means change in temperature. So let's type that on there. Or change in temperature. All right. This next part, that M. Of course, we know that M, right? I hope we know it. That's molality, so let's type that in there. Molality, not molarity. That I, and that I was on one of those papers for the chemistry kids, not so much for the other ones, stands for the number of ions. So let's type that in there also. For you guys that are so hip, that doesn't mean that that's a hashtag on Twitter. That means number. And then K. And K is a constant. And we'll just put the word constant there. Now there's more than one constant. There's two constants in this thing. Actually, there's a whole bunch of constants. But we're only going to deal with water, so we're using the constant for the freezing point and the constant for the boiling point. They are separated by a little teeny f or a little teeny b, depending on which kind of problem you're solving. All right, so let's go right to the problem and see if we can solve one of these. Right here is some helpful information in case you forget or you're going on your own. If you're going on your own, you want to have that information. But I would listen maybe the first little bit. It's up to you. Okay, here we go. Problem 1. A solution of calcium chloride. And I just made up different solutions. And notice I put little numbers down here because we're going to have to find out the number of ions. Remember we talked about that dissociation, right? So we talked about the number of ions that form. That's why those numbers are there to help you out. A solution of calcium chloride freezes at negative 15 degrees Celsius. Calculate the molality of the solution. All right, I have this set up for us in the probably the most efficient way possible that I could think of to make sure you know all the pieces parts. So first of all, what is the temperature? And so go in here and copy that temperature. Oops, I guess I only need negative 15. Now, if you want to type it, hey, more power to you. Right? Now, the temperature's negative 15. What's the change in temperature? You have to ask yourself, when does water normally freeze? This is freezing, right? So when does water normally freeze? Well, it normally freezes at 0 degrees Celsius. So how far is the temperature away from the original? It's 15 degrees. It's the same number. Now, I put that on there because in the boiling one is not going to be the same number because water boils at 100. We'll get to that in a little bit. Here's Kf, and Kf is because water is the way it is. And when water freezes, this is the, when water freezes compared to when it's a solution, when it's in a solution, when it's the solvent, this is the effect that those little particles, remember what Professor Dave said, those little particles getting in the way, interfering? This is the effect that those particles have for water. It doesn't matter what the particle it is, all it matters is that it's in that solution. So we have that number, I put that there for you. And then the I. The I is the number of ions. Let's look at this right here, Ca. There's one Ca and there's two Cls. To me, that adds up to 3. So that would be 3. All right. So we have all of our information. Now let's put it in the right spots. What's the change in temperature? Well, that's 15. Copy. Paste it in. It's not going to let me copy and paste it in. Let me try that one more time. If it doesn't work, I'll just put it below. Copy. Paste. Oh, sorry about that. We'll just put it below. So negative 15 equals M. What's M? Oh, M's what we're trying to solve. Okay? And so let's just plop an M in there for right now. Times Kf. Kf is right here. Let's put that number in. Copy. And you can put a times or parentheses. You know I like those parentheses because they're so cool looking. And then finally, what do we have left? The number of ions. We have a 3, and I'll put that in there also. Okay, now look what we have. Our equation just like before. Now we have an equation with, well, it has 4 different things in it, but we're trying to solve for M. So we have to get these 2 things away. Right? If they're on the top and we want to take it to the other side, we move it down. So we're going to divide. In the calculator, which my calculator went out. Let's see if I can get this back in quick. It'll probably be cut. Check, check. 1, 2, 3. Waiting for my thing to work. Okay, now I have my calculator up. So what do we have here? We're going to have 15. All right. Let's have 15, and it's a negative 15. So remember, always start on the opposite side of the M. So we have 15. Oops, I'm sorry. I'm trying to type it in my calculator with the screen. So we have 15, the negative sign on there. I use the positive and negative button. The positive negative button, not the minus sign. Divided by 1.86, and that's also a negative, so push that button again. And then divided by 3 equals, and I got 2.7. All right, and we'll put that number right here, and that'll be our answer. 2.7 little m. So that's the concentration of the solution. So we can tell how much stuff is dissolved in that by the temperature which it freezes, which is super duper cool. All right, let's go to the next problem. Now this problem's the same exact way, except this time it's boiling. So first of all, what's the temperature? A NaCl solution boils at 112 degrees Celsius. You know what? Copy paste. And make it fit. Why aren't you fit? Oh, that's because we have that Celsius thing in there. There we go. So 112. Now, what's the change in temperature? Well, you have to realize that water usually boils at 100. So if water boils at 100, that's 12 degrees difference. So the change in temperature was 12 degrees. Does that make sense? It's a 12 more than it should have been if it was pure water. Okay, how many I's do we have? It's NaCl, 1 and 1. Our I's, our ions are 2. It splits apart, dissociation, boom, 2 ions. Fill in your blanks. So we have, remember it wouldn't work last time, so let's do it this way. So we use the right one. It's delta T, so 12 equals, we're solving for M. I like the parentheses. So we have 0.51, and you have to use that. That's the effect it has on boiling. It's different than freezing because it's not forming a crystal. It's not forming that lattice structure. It's evaporating, so it's going to have a different value in there. And then, of course, our I, which is 2. And so what do we have? Again, cross multiplication. M equals 12. Always start with the other side. M equals 12 divided by 0.51 divided by 2 equals 11.8. That's a really high number there. I don't think that salt would really dissolve that much. I didn't make this problem up. I just stole it. So it seems a little fishy to me. I don't know if we could get 12 molality solution or not, but hey, we know how to do the problem though. Next. Okay, this time we have a 1 mg Cl2 solution. It has a concentration of 3m, so let's put that 3 right there where it belongs. See what we're doing there? Calculate the boiling point of the solution. Well, the next thing we're missing is I's. MgCl2, 1, 2, 3. We have 3 ions. I'm just counting those up. That's it. Now, put the things in the right spot. So we do not know delta T this time. So let's just put T because we don't want to mess with the delta sign. So T, or you can copy paste it, equals 3 times, now this is K, oops, it says KF there, but this is supposed to be boiling. It should have said KB there. I can't change it, I don't think. Nope. So I have KB up here, so make sure you use this number. It's boiling. Make sure you use the right one. My equation, I kind of messed that up, but, you know, let's pretend I didn't. All right, so we have that in the right spot. I'm going to adjust it. There we go. So it looks nice because why not? Now, we need I's, right? So how many I's did I say we had? We had 3. We already figured that out. We'll put it in the equation. And so we have everything on the same side. It's going to be a straightforward thing. So it should be 3 times 0.51 times 3 equals 4.6. The change in temperature is 4.6. That's not the temperature that it boils at, though. It's going to boil at 4.6 degrees higher than the normal boiling point, which was 100. So that should be, according to my calculations, 104.6 degrees Celsius. Boom, we got it. All right. You know what? We're on a roll. Let's not stop it. You have a LiCl. Ions are 2. And you have a concentration of 3M3. Calculate the freezing point of the solution. Oops, I didn't put the delta T. Oh, we're solving for delta T. Never mind. Calculate the freezing point of the solution. All right, fill in this equation. So again, we don't have T. It should be delta T really there. You know what? You guys are worth it. I'm going to copy and paste that on there because you guys are worth it today. And plus it looks really neat. Uh-oh. Well, I guess I'm not going to. Okay. And this equals, get that out of the way, m. So little m is 3. Boom, 3, boom. Kf. So, and again, negative 1.86. Parentheses. I'm just going to make mine look pretty. And then finally, the i's. And the i's are 2. So we have 2 i's. Hey, we do have 2 i's. Remember, it's a negative. Now, if you don't want to put that in your calculator, you don't have to. You can always add it on the end, but I like to put mine in. So 3 times 1.86 with a negative sign times 2 equals 11.6 degrees Celsius is the change. 11.6, not 11.6, Mr. Arnold. Negative 11.6. Well, it usually freezes at 0, so how much is that off? That's off by the same exact number. So negative 11.6. The freezing ones are going to be the same. I put that on there because of the boiling one, right? And then we are done with that paper. So if you had any issues with that, hopefully you just watch the video again. All right? Make sure you do the first part with Professor Dave. And peace out, man. That wasn't too bad, was it? And I will see you in the future. Awkward time when I could try to turn off the video. Boom.